Today we're going to be talking about the accessibility of the UMass Amherst campus. These slides and data were done by Jack Merrigan, Andrew Ola, and Victor Moffo. UMass Amherst is one of the most popular destinations for students from the New England area. Although the campus is one of the top in the nation, a frequent question asked is how accessible it is for people with mobility issues. When brought to the Massachusetts Daily Collegian, they ultimately answered that it isn't that accessible because their elevator doors had been broken for 4 weeks, as well as their automatic doors. As a result of this, everyone has to funnel through the other door, and it creates traffic jams and makes it less accessible for people with mobility issues. Our goal with this project was to survey the UMass campus with the skills we learned throughout the semester to determine whether or not the campus is accessible to people with mobility issues. In order to reach our goal, we had to come up with a plan. Our plan consisted of determining if the slopes were ADA compliant. We did this by measuring various areas on campus, such as the path from the Worcester Dining Commons to the UHS and back, also Marston to Mullins Center and back. As well as that, we surveyed around other areas that other fellow civil engineer students who were given the same task surveyed. Throughout this project, we used various equipment such as a leveler, measuring wheel, rod, total station, and more. The equipment used is what civil engineers use on a daily basis while working in the field. The measuring wheel was used to track our 50 to 100 foot distances. The rod was used to measure the heights of our points. And the total stations, they were a lot more advanced, but it was used to measure the distance between points.
ADA compliance. ADA stands for Americans with Disability Act standards for accessible design, essentially preventing discrimination against people with disabilities, enacted into law in the 90s. This does not apply to just transportation, but all businesses as well as websites. MassDOT Transportation of Department of Transportation states in their guidelines that all sidewalks and walks, regardless of material shall be designed and constructed with a cross slope of 1.5%, with a construction tolerance of plus or minus 0.5% allowed. This means that if we measure a slope of 2% of less, we deem the path ADA compliant. Our first experience with surveying was in Lab 5, conducted in the week of March 25th. This lab was our first experience with a typical survey equipment. The task was to conduct a circuit survey from Marston Hall to Mullins Center and then back to the starting point. A closed circuit just means to conduct a survey path that ends back at the starting point. Due to the inexperience of our group with the equipment, the circuit was not completed and we ran out of time. The portion of the circuit completed is shown in the image, with each dot representing a point. To determine if the area was accessible, we need to consult the shared data sheet of the lab. According to Group Rail, the average slope of the area was about negative 0.885%, which seemingly is compliant with ADA standards. However, looking at the data, some slopes between points have a large, sharp decline, such as the first and last slope, which would not be compliant. Our next experience in surveying was conducted the week after the last one. This lab used the same equipment to survey the area and paths of Worcester Dining Commons to the University Health Services building. This survey was more successful than the last survey, as it was more efficient. The path we took is shown in the image, with the two paths starting from Worcester, but either using Thatcher Road or Stockbridge path to end at the UHS building. Each dot on the path represents a point. The average slope of the entire survey was about negative 2.9%, which exceeds ADA compliance. However, breaking up the circuit into two separate paths results into two paths being deemed ADA compliant. However, some slopes in between individual points have a sharp increase or decrease, which would be hard for those to handicap to traverse. On a surface level, the campus seems to be accessible so far. Our first experience with topographical surveying was conducted in lab the week of April 15th. This was our first time using a total station. The goal of this lab was to survey the elevation change around the engineering quad area by Marcus and Marston Hall. We then collaborated with other groups in the class to compile our data into a topographic map generated by a program called Civil 3D. A topographic map is essentially a map that shows the elevation change of an area using contour lines. Our group decided to focus on the perimeter of Marcus Hall, with points being close to one another. The measured slope of that area is about 0.4%, and we assume that slope to the rest of the engineering quad, as the area was flat enough with no sharp changes in elevation. By these measurements, the area of the engineering quad is ADA compliant, with pathways and easy accessibility for everyone. Furthermore, we compiled this data into Civil 3D to get a detailed topographic map of the quad, with contour lines reflecting the spaced out small elevation changes in the area.
Our second experience with the total station was during the second lab mentioned in the last slide. This time we had a choice of where we could measure elevation changes, and we chose the pathways in front of Gozman Lab as shown in the photo. This area is highly populated with students of all abilities, so we thought it would be perfect to measure the elevation changes. This lab was done a lot quicker than the previous since we had experience with the equipment beforehand. We shot a total of 50 points during the session, usually outlining the pathways and grass. We got an average slope of 0.5%, which complies with ADA guidelines. Furthermore, the area was very wide, smooth pathways, which would be accessible for those who are handicapped. The information we gathered from this lab indicates that a lot of the areas around the northern and eastern parts of campus are accessible. This brings the question, is campus truly accessible? According to the data we recorded this semester and what we have summarized, yes. But this is only looking at the generic slopes of each of our surveys. Looking into specific data gathered, questions start to be raised. For example, in both of our circuit surveys that involved Marston and Worcester, there were many sharp slopes, especially the path from Worcester to the UHS building through Thatcher Road. Although it was not examined, the hill up the central residential area does not even need to be measured to dictate that it is inaccessible, limiting those who are handicapped from traversing the area. True, all the areas we surveyed met ADA compliance in terms of slope, but that is only the bare minimum. Campus infrastructure is outdated. Even during the surveying, some roads and pathways were old with many cracks, especially Stockbridge, once again limiting accessibility. Furthermore, campus is so large that it is hard for those who are handicapped to get from places they need to places they need to go, either requiring a bus or another form of transportation. After some additional research, it has become apparent that UMass has accessibility issues outside of infrastructure, and we found an article from Shannon Moore, a student of UMass. She writes about the inaccessibility issues of campus, including elevators never working, the many flights of stairs, and how most doors do not have automatic door openers. She writes, "The landscape is often rocky and narrow, elevators don't work, the list goes on," once again reiterating our point. While UMass meets the bare minimum for accessibility, it has plenty to improve on. What are some ways that UMass can improve accessibility? Simple, invest in renewing infrastructure. Many pathways and roads can be repaved to reduce cracks or bumpiness like Stockbridge Road mentioned earlier. Furthermore, some new pathways can be created that can be easily accessible for those who are handicapped. Ensuring a wide, smooth pathway, some pathways can be revised to find a way to decrease their slopes. It would also help accessibility if more transportation options were available outside of a bus, such as having more transportation cars available at a time. Furthermore, as Shannon mentioned earlier, UMass needs to be more on top of repairing accessibility items. This includes elevators, door openers, and other essential needs for those who are handicapped. With these commodities out of order, some people cannot even access some parts of campus. UMass has a lot of room for improvement in terms of accessibility and needs to take action to improve campus to make it equal for all.